Alright, we finally got to the point where we're going to start talking about object-oriented programming. The most natural question that you may ask yourself at this point is, what is object-oriented programming? And the most obvious answer for that is that this is a kind of programming that depends on objects. The next more natural question would be at this point, what is an object? And the answer to this question is both very easy, and at the same time it's very hard to grasp in the beginning because it's something that is very abstract. For example, as you can see here, I have written a couple of examples of objects. Well, basically anything can be an object. The person can be an object, the car, the calculator, the glass, Facebook. Your fingers are objects. Everything is an object. Anything that can be described with a given set of properties is an object. So at this point you may ask yourself, what are the properties? The properties are the variables that describe a given object. For example, a person has a height, weight, hair color. These are some of the properties that can define a given person. The objects can have their own objects within them. For example, the car has an engine. The engine has its own properties. So you can see very quickly, when we start digging deeper, we kind of create different layers of objects and of properties that can define one bigger object. So if our main object is the car, for example, that car has engine, it has tires, transmission, headlights. All of these are different objects that are within the car object. They in turn have their own objects. The headlight have light bulbs. The way that we describe these objects with these properties is by creating a class. The class is the thing that holds everything together. The class holds the properties of the given object. In some cases it can also hold the objects that are within the object, so this is called an internal class. So a class can have a class inside the class. Like I said, a given object can have many layers of objects below it. We are no longer limited to the primitive data types. Classes allow us to create our own custom data types, which at their lowest level are described by primitive data types. You're probably asking yourself at this point, why do we have to bother with object-oriented programming? Well, the most obvious reason would be that it lets you organize your code much easier, much better. We are no longer limited only to our entry point class and our main method. We can create our own classes. Each class can have its own file. So this leads to much better organization of our code, of our files, of our projects, and this in turn leads us to much easier maintenance of the code. We can much easier extend it. In general, it's just much easier to be understood once you grasp the object-oriented concept. For example, if you have a car and you want to change something on that car, for example, you want to do something on the engine that will make the car more powerful, you don't have to go and change your paint first and then do the engine. You just go ahead, open the engine, change the internals or whatever you want to do to the engine. You put it back together and your car is still running. Well, it may not be running, but the rest of the systems of the car are still going to run. Those that are not dependent on the engine. So for example, your headlights are still going to work. They are not dependent on the engine, they are dependent on your battery, for example. So this is the main thing behind the object-oriented programming. It lets you maintain your code better, you can understand your code better, and you can much easier extend it if necessary. And it's always necessary to do this.